G'day, this is Andrew Johnny, and this is the recording for assignment 2 for ELE2303, Embedded Systems and Design. Okay, so what you can see in front of you here is the main control algorithm for the greenhouse controller. This first part here calls the initialization subroutines, which takes care of setting things up such as registers that are needed for the program. Then it jumps into an endless while loop, as you can see. First thing it does then is check that it occurs every 1 second. So this part of the code will only run once per second, okay? Further details on that will be provided within the report. This next part here deals with the delay between the valve and the pump triggering, the 1 second delay. It also is responsible for triggering the fan or the vent if needed, okay? Again, you can look at that more in detail in the report. One thing I'd like to say before I continue is this is actually a dual state machine. So what I mean by that, there's two groups of states. The first group of states consisting of temperature states. You can see here, I'm highlighting them, okay? And the other group of state are associated with the light level, so the luminosity or the lux, and that's these ones here, okay? So what I would like to say about these two groups of states is they can't actually affect one another. So the light level states, for example, can't call the temperature states and vice versa. They have no impact on each other, but they both can control different devices. For example, you can see here in the light level one, the fan here is being activated. So different devices can be activated or deactivated in either state, either group of state. All right, here's all the subroutines in here. Don't really need to go over that in too much detail. The report covers that. And here's the header file. This part here, these are the delays associated with the fan or the sprinkler. So as you can see here, I've reduced it down to a factor of 20 seconds as opposed to an hour for the fan runtime, and the sprinkler runtime down to 10 seconds as opposed to half an hour. This value here, it was calculated. That's the value that gets put into the timer overflow register to allow for a 100 millisecond delay for the interrupt service routine. I've noticed that value there actually causes it to delay a little bit too quickly. So to counteract that, we multiply it here by a timing factor of 1.1 to counteract that, okay? And the last thing I'd like to say is this line here, basically what that's used for is the program can be run in two different modes. So a standard mode, which is what will normally be run it, and testing mode. So when I'm showing you the recording, we're going to be using the testing mode of operation. Basically, the testing mode will basically show some display of what the routine is actually doing. For example, if the fan is turned on, it'll say on the display, the LCD display, fan on, and when it's turned off, it'll tell us that it's turned off. So that's basically what that does there. So I'll bring up the PicSimLab here. I've just compiled it and run it. As you can see, the first thing that comes up here is the set temperature routine, which is a requirement 2. You can see the first one that come on was 40 degrees. And that can be changed. This is the maximum temperature threshold that can be changed by using the buttons. You can notice that they go up and down by increments of 2 degrees. So the maximum it can go is to 46 degrees. I can't go any higher if you hear my clicking. And you can also go down to a minimum of 36 degrees. All right. So I'll just set that to 40 degrees and we'll begin the program. So that there, this part here shows the temperature and the luminosity. This display subroutine is called once per second, but within that subroutine, it actually it will only redisplay the value on the screen if there's a change in that value. For example, the 26.2 degrees here, that doesn't change unless I actually change it. So notice it took about a second for it to refresh, depending on where it is in the thing, but it doesn't actually refresh until it detects there's a change in the value. That's the same thing with the luminosity as well, the lux level. Okay, so requirement 2 is done. Requirement 3's got to do with the sprinklers. So the first one here, it must run once each day when the light level falls through 5,000 lux, but only if the temperature is above 6 degrees. Okay, so we're at 28.2. We can start with the first one. We'll see what happens when the light level falls through 5,000. Okay, so we're way up high there. So it'll fall through 5,000 and the sprinkler should go on. This here is the valve and that's the pump. Okay, so when these two are on, that means the sprinklers are on. Now remember, there's a 1 second delay in between them. We're just over there. I'll go a little bit more. There we go. So that should go on for 30 minutes, or 10 seconds in this case, because we're testing, and then that'll turn off. All right, there you go. The next thing we'll show you, I'll try it again with the temperature below 6 degrees, and then that should not activate the sprinkler. Before I go below 6 degrees, I would like to note that that will turn the buzzer on. The buzzer can actually be turned off by pressing the down button, or it will be turned off by returning to normal temperature, which is above 6 degrees. Okay, I'll show you that buzzer part first. So as you can see there, it turned off when I pressed that button. It'll also turn off if I go above 6 degree mark. But if you notice, if I keep pressing that button, nothing happens. It doesn't re-trigger it. So I'll re-trigger the buzzer, and then I'll turn it off by rising back above the 6 degrees first, okay? There you go. I've noticed that you can't hear my voice when the buzzer's going, so I'm trying not to speak when the buzzer's on. Okay, so we'll go below 6 degrees. I'll turn the buzzer off, and then I'll try the light level thing. All right, now we'll let the light level fall below 5,000, okay? So we'll click that on, and the sprinkler should not turn on this time. There, see, nothing happened. And we'll just test it one more time when it's above 6 degrees. We'll just double check. So there you go, it turns on. That works perfectly. So the next one for the sprinklers is it's triggered when the temperature rises through 36 degrees, okay? So we'll get up right on the borderline of the 36 degrees, and then we'll get it going from there. I might time this one so you can see what the timing's like. So when that goes over 36 degrees, the sprinkler should turn on for 10 seconds. All right, ready? All right, we're timing that. I'll turn the timer off when this light turns off. There. Yeah, we'll see there's a little bit of a delay with my pressing of buttons, so it is pretty close to 10 seconds anyway. Okay, so as you can see, the sprinkler got triggered above 36 degrees. The next requirement is that the sprinklers are triggered once it rises through the maximum temperature set point, which is in this case 40 degrees. I would like to mention the buzzer will go off with this one as well, so I'll turn that one off as soon as I can so you can still hear what I'm saying. I'll get right up against that boundary. That's pretty close. All right, and go. All right, so the sprinkler's on. I did turn that buzzer off, yep. So sprinkler's on now. Yep, it now opens vent. You can see a little subroutine there. I'll go over that in a bit more detail later on, but we'll turn it back to normal. And then we'll look at the next requirement. Okay, so the sprinklers, the requirement 3 works perfectly. We've tested all that. Requirement 4 is to do with the fans. So the fan must run for an hour each day when the light intensity rises through 1000 degrees. So there's no other requirements for that one. So if it rises through 1000 degrees, the fan should go on for an hour. In this case, it'd be 20 seconds, okay? So you can test it all for yourself in different temperatures, but it does work exactly the same regardless of what temperature you're going at. When it goes through 1000 lux, it'll turn it on regardless of what temperature it is. All right, so I'll get right up against that. That was a bit out, but we'll see how close we are with timing. Try and get to 20 seconds. All right, the fan's off. So as you can see, it's fairly close to 20 seconds there. All right, so that first requirement works perfectly. The next one is the fan must be turned on after the sprinkler stops and the temperature exceeds 36 degrees. Okay, so we'll just simply rise it through 36 degrees and then wait till the sprinklers stop. Okay, so the sprinklers are on. Once the sprinklers turn off again, it should turn the fan on. And then the fan will stay on until it falls back below the 36 degrees once again. So that'll stay on. And once I go below 36 degrees, it should turn off. There you go. All right, so the other thing as well is if we turn it on and then after the sprinkler stops, just say, for example, it falls back below the 36 degrees or the sprinkler's on, the fan shouldn't turn on. All right, so notice the fan did not turn on this time because it was below the 36 degrees. So that's met that requirement perfectly. Requirement 5 is to do with the vent. And it says the vent is to be opened after the sprinkler stops and the temperature exceeds the maximum temperature set point. So that's very similar to the last one we just showed you there, but this time it's when it rises through the set point. All right, so we're just on the borderline of the set point here. When we go through, the vent should become open after the sprinklers stop. Okay, I'll turn that buzzer off because you can't hear what I'm saying. But yeah, after the sprinklers turn off, the vent will trigger and it'll show a little animation display down here. See that? Now we need to press the limit switch, RB3. Now the vent is open. Okay, so that one there, that requirement for requirement 5 works perfectly. Okay, so when we drop below the 40 degrees, the vent will then close. Okay. After this, I'll actually show you the buzzer can be turned off by just dropping below the 40 degree or the set point, as opposed to pressing the button. We've already tested the button for turning off the buzzer at the top end. We'll just drop back through the temperature. Yeah, see that? Just do that again. Yeah, see buzzer turned off. Okay. So you can trigger it on and off by 2 separate ways. Okay, so just set it back to the standard range again. So that's the requirement 5 is done. Requirement 6 and 7 are actually to do with the buzzer. I've just shown you then, they work perfectly. Requirement 8, so when the user presses and holds the enter button for 1 second, the user is prompted by the LCD to set the maximum temperature set point. Okay, so no matter where we are, whatever state we're in, we can press and hold this button for 1 second and it will take us back to set the maximum temperature threshold here. Okay, so as you can see, we can just edit that if we want to, and then it continues to run as normal. So you can do that at any point within the program. It'll jump to that. All right, that pretty much wraps it up. But yeah, the requirement 9, I showed you that at the start. displays the temperature and light level once per second. I explained all that to you. So that wraps up the demonstration for the greenhouse controller. Thank you for your time and patience.